Hello and welcome to our Sectigo webinar, part of our root causes series, and our topic today is PKI for IoT. This webinar will be, my name is Tim Callan, I am Senior Fellow at Sectigo, and I am kind of our interviewer today, and our subject matter expert is Jason Soroko, CTO of IoT at Sectigo. How you doing today, Jay?
Really good as always, Tim.
Yeah, so Jason and I do run a regular podcast, and don't worry, I will shamelessly plug it later in the webinar. So we do this kind of talking a lot, so hopefully this is pretty good for us. Today we are talking about the right way to structure and run a PKI implementation for Internet of Things. It's a little different than how you might do PKI for other use cases. And this will be about a 30-minute, we're estimating this to be a 30-minute webinar, more or less. We do love questions, but we do have a lot of guests today, so we can't have the lines open because we always hear somebody's dog barking and a siren going by. So as a result, everybody's muted, but you can send your questions via chat, and you should have a chat interface that looks like what you see below. So just put your message in. We will receive it. We also are joined by our friend and coworker, Mark Anthony Gaunt. Mark Anthony will be keeping an eye on your chats. So he will either ask us during the webinar or ask us at the end or reply to you directly in text if it's kind of a one-on-one thing that the whole group won't be interested in. So with that, why don't we go ahead and start talking about PKI for IoT. Jason, take it away.
Hey, Tim, thank you. Yeah, this is a good map. And I think what we're trying to illustrate with looking at something in a geographic sense is what is the risk landscape in terms of its size for IoT. And when you take a look at something like a map produced by the folks over at the Shodan search engine,
Mm-hmm.
it really shows that the exposure of publicly connected nodes that aren't necessarily just routers or PCs or mobile devices, the typical thing that'll go off and connect to the internet. This is a map of, it's almost a map of the world that everywhere that has and uses electricity. This is, that's pretty much how ubiquitous it is.
Right.
And these are IoT devices that are publicly connected to the internet. And quite a lot of these devices really shouldn't be. Quite a lot of
Right.
these devices are connected to the public internet for the purposes of, let's call it convenience, because it's a heck of a lot easier to just go to an IP address with your web browser from home or from, you're wearing a hard hat, you're sitting in a truck, you need to connect to a wellhead, you need to connect to an industrial controller. So therefore, a lot of these folks will put, web server connect, IoT devices that actually have a web server and connect them directly to the public internet and rely on a username and password to log in, Tim. This is a map of what we're seeing here.
Right. And so where this came to play, right, where this large number of publicly connected devices really reared its head, of course, was one of your favorite topics, Jay, the Mirai botnet. So what did we learn from the Mirai botnet?
The Mirai botnet, of which, Tim, the source code for it was leaked and it is available publicly.
Mm-hmm.
Which, if you think back to the old Zeus virus, which was a financial institution virus that attacking people's bank accounts, etc. Um, once source code for a virus has gone public, then you're going to see tons and tons and tons of new variations to the point
Right.
where the name Mirai actually doesn't almost mean anything anymore because it's morphed into a million things.
Yeah.
The Mirai botnet, the way it worked was to really, I almost think it was meant as an illustration of just how vulnerable most devices that are sold into the market are. They quite often devices are shipped from the factory with default username and passwords that are either never changed or
Mm-hmm.
there's no capacity to change them whatsoever, amongst dozens of other vulnerabilities such as open ports, and really showing there's not a lot of security in a lot of IoT devices that are being shipped today. Obviously, there's exceptions, and thankfully, we'll talk about some bright lights of where there is security today. But for the most part, the reason we see a map like this one
Right.
And the reason why we still talk about the Mirai botnet and the reason why it's
Yeah.
still relevant is because of the prevalence of static credentials and the fact that default username and passwords are still being shipped from the factory.
Yeah, and I think the Mirai botnet really illustrated for a lot of people, myself included, just the scope of this particular attack surface. Like I remember when those DDoS attacks started coming out and targets that were considered to be unbreakable were being slowed down incredibly or taken offline by the DDoSes, and it was just because nobody had anticipated the amount of power that someone was going to be able to throw at this kind of attack. And the Mirai botnet really opened a lot of people's eyes for that. I think an expert like you, Jay, probably already knew it was just a matter of time. But in my case, I was completely surprised and amazed when it happened. And I think most people, even in the world of IT, were surprised and amazed by that. And it was a big eye opener for a lot of people.
Yeah, we've also seen, unfortunately,
Right.
this has been continuing.
Yeah. So you were mentioning static credentials. So
Yeah.
static credentials just on your own computer is bad enough, right?
Yep.
But when you start to roll that across an IoT kind of network, it is, pardon me, super bad. I just couldn't resist this.
Yeah.
Jonah Hill is so young in that picture. It's incredible. Anyway,
Yeah.
so yeah, I mean, and why is it worse in an IoT environment than just us doing that individually?
We were talking about devices uh, that are typically headless, right? These devices, it's not like a human being who is authenticating into a cloud service or a human being authenticating into their ERP. We're
Right.
talking about devices that might be connecting to other devices or devices themselves waiting to be connected to. And things such as, password change policies, which used to be a thing, Tim, back with
Hmm.
NIST, and then they got rid of it. All of these things with username and passwords, it shows you it was a bad authenticator. It was a weak authenticator for human beings.
Right.
It's an even weaker authenticator for devices. And I
Right.
think we might get into this, but in terms of legislation, that doesn't go far enough. But one of the most terrible things we see is
Right.
you'll see devices which which will even be able to change, or be forced by legislation, as you see on this screen,
Right.
legislation that will actually force vendors to actually put in some level of capacity to change the username and password. It won't force the actual end user to do so, first of all,
Hmm.
but at least the technical capacity to change the username and password is there.
Right.
But in the end, the legislation says nothing about forcing things like TLS encrypted sessions.
Yeah.
And and
Yeah.
and
So
the world that
so
you come from, Tim, the public
yeah.
trust world, we've already gone through this, which is it should be everywhere. TLS encrypted sessions should be everywhere, and it should be everywhere with IoT. We don't have that in the legislation yet.
Yeah, and so let's maybe let me clarify one point, right? So the static credentials, one of the reasons the static credentials are bad, one of the reasons is they tend to be reused, right? So you can imagine somebody pumping out hundreds of thousands or millions of devices. They all have the same credential. So if you can steal one of them, you can replicate that across all of them, right? So you magnify the magnitude of the problem in the event that it's stolen. And stealing it for even one can be bad, but now you start imagining stealing it for 10,000, 100,000, it's considerably worse. But then second of all, the point on this legislation is if you allow the password to be changed or force the password to be changed, and that isn't TLS encrypted, then that means that information is being sent in the clear. And if it's being sent in the clear, what can happen, Jason?
It is almost zero effort for the bad guy to actually scrape that right off the
Right.
wire and then do what they like with that device. And quite often, that one credential gives them, from a technical standpoint, root level access to the devices. So
Right.
this monoculture of credentials, static credentials that the same username password going being sent with the devices for millions and millions of devices. This is precisely how you have a map like you saw previously. It's precisely how the Mirai botnet is able to harvest millions and millions and millions of IoT devices, internet-connected IoT devices, seemingly effortlessly. And you've just specified what the reasons are.
Right. But on the other hand, on the upside, legislation has come, right? California Senate Bill 327 is a real thing. It's going into effect the beginning of the new year. There's federal law following, also proposed legislation in the UK, and I will bet you a bunch of other places. And one of the important things to remember is if there's a law in one place, let's say California, and you're manufacturing a device for distribution across a broad geographic region, that kind of becomes a de facto rule for everything, because nobody's going to bother
That's
having
right.
a different product in California than they have in Washington State. They're just going
Yeah.
to sell the same product. And so it winds up effectively being a US wide or even larger requirement.
That's exactly right. If you want to deal with the U.S. federal government after this, I once had a question from a colleague. So, what kind of use cases is the U.S. federal government involved with IoT? The answer back is all of them.
All of them. Absolutely. All of them. All right. There are a lot of reasons why PKI is a better way to handle identity for your IoT devices than static credentials. And I just took the liberty of listing some of the obvious ones to me here. Do you want to comment on this? What do you have to say about this, Jay?
Sure. I think that we've just talked a lot about static credentials. We could even get a little more technical, talk about things like essentially static tokens, right? Which
Right.
sometimes are just shared secrets, which essentially just means there's a password sitting on within the word symmetric means that there's a shared secret, which could be an alphanumeric string of characters that's known by both parties that are authenticating to each other. And
Mhm.
obviously there's problems with that because of the fact that if it's stolen from one end, the bad guy can work itself into the communication. PKI got rid of all those problems decades ago.
Yeah.
And this is the reason why we use symmetric secrets, right? Symmetric could be private keys. They could be within a certificate. There's all kinds of ways that we implement PKI. But suffice to say that the whole concept of managed asymmetric secrets, if you want to make it generic as possible,
Mhm.
is what gives you all these bullet points. And it's
Right.
been around forever. It really is the natural solution to solve what the Mirai botnet is proving to us, and what a lot of the other attacks. If we chose to talk about the Mirai botnet on this webcast, but we could have chosen a dozen others, and saw that it really was either a complete lack of authentication, mutual
Right.
authentication, or complete lack of TLS encrypted communication sessions. But suffice to say, PKI it was designed to solve that multi-decade time frame ago, and has
Yeah.
proven to do so.
And that's such an important point. That's part of the reason I stay in the PKI industry is this is so proven and so reliable. Like it's hard to come up with an element of our computing paradigms that has worked so successfully for so long with such the same basic scheme. So we change a lot of the details, but the basic concept really has worked since the 80s on our computing platforms very successfully. And one of the consequences of that is that it is incredibly versatile, it's adaptable. You can use it in all parts of your computing platform because support is ubiquitous, and the basic concepts and how to use these building blocks are understood by industry people, software developers, hardware developers, all of those places. There is just complete understanding of how to do this successfully, and for your IT professionals who are going to implement. So the level of knowledge is also very high, and all of that makes PKI just an excellent platform.
Yes.
But it has some baggage.
It definitely has had baggage. Um, if you think about large financial institutions, you think about government rollouts, passport systems, citizen ID, even large corporate enterprise rollouts. Um, uh, Sometimes they can get very, very complex. And
Hmm.
one of the revenue models for companies that are PKI vendors was to sell a heck of a lot of professional services.
Right.
And so therefore, by definition, it was going to be slow, it was going to be painful, and it was going to be expensive, which is
Yeah.
if you're an IoT device vendor, it basically disqualified the technology.
Right.
And still, when I go to conferences, Tim, I'll have people who they know what company I work for, and they'll talk to me about my technology. And one of the concerns they express is, yeah, I'd love to even just do a demo with you, but it's going to take 9 months, going to cost me $1 million, and I won't even know if
Right.
I like it.
And so
And
this, right. Go ahead.
and that just comes from their experiences from the recent past.
Yeah. And so the solution to that is, hold on, I have changed my focus. There we go. The solution to that is purpose-built PKI.
Yeah, thankfully things have changed, Tim. So
Right.
I've been working on a PKI and IoT for quite a few years now, and what we've done is we've realized in a really big way, IoT device vendors, they're very price sensitive. It needs to be the solution needs to be economical. It needs to be able
Hmm.
to roll out super quickly. Um, don't give me a user interface that requires a 20-year, grizzled PKI, sales engineer veteran to have
Right.
to muddle through 24 hours a day. Oh, and by the way, I'm not talking about 50,000, 100,000, even a million human users. I'm now talking tens of millions of devices that I want to be able to issue certificates to. So it obviously needs to be scalable. And so something that does all of this, and even a few more that we could put on this list,
Right.
we've now, PKI has evolved to be able to handle the IoT use case where it is the ideal security solution.
Right. And part of the way this works, right, is that the needs, we hinted at this in the beginning, the needs of an IoT use case maybe are a little different than the needs of another PKI use case. And that's where the purpose built point comes in, right, but Jay, because you can get a solution that is geared to the specifics that you want to have. It could have to do with being able to provision your devices differently. It could have to do with just being able to handle the scale. All of those capabilities are pre-built so that I don't have to sit down and sort of engineer it from scratch, right? It's the difference between engineering it and configuring it. Is that a fair description?
Yeah, it is. There used to be just so much setup. There used to be have to be so many use cases, financial,
Right.
corporate, you name it, that those PKIs were unfortunately engineered by engineers,
Hmm.
and basically the usage of them became so utterly complex that they were difficult no matter what job you threw at them.
Yeah.
And for IoT, it just couldn't be that way. It needed to be stripped down to its bare essentials and just be really, really good at it. And that's thankfully where what we've evolved to.
Right, and so that's what gives you the usability part that, I don't have to be, as you said, I don't have to be a grizzled expert. I just have to understand my needs, my devices, my supply chain, and able to put that together. It's economical as a result, right? And part of that's also just a function of having the right pricing model, right? At $1 a
Yep.
cert, this can't work.
Yep.
So it has to be priced correctly. The scalability, of course, we're looking at things, put a 0 or 2 or 3 at the end of the number of certs you ordinarily would be expecting to issue. So you have to make sure that you can handle that. And then, agility. We've talked about use cases where certificates expire very, very quickly. I know one of your favorite examples is, maybe you put a new certificate every time the airplane takes off. And if the airplane flies 3 times a day, you're issuing a certificate for that one element of the airplane 3 times a day.
Right.
So all of that is specific to how we approach it from an IoT perspective.
Absolutely, Tim. The use cases in IoT are even more varied than the ones you'll see in traditional PKI, and that's another reason why purpose-built PKI is just so important.
Right. So, and then interoperability. Talk to us about interoperability, Jay.
Um, Static credentials and things like symmetric tokens,
Mhm.
those, those kinds of things, you can't, unless you go off and share the password or share the symmetric token, the shared secret off with whatever other vendors you're dealing with, which is incredibly insecure and a gigantic management pain in the butt.
Mhm.
The thing about we see in IoT is enormous numbers of devices are needing to interoperate across third parties. It's not just I need to cross a network boundary and authenticate across it, which is
Right.
obviously the obvious use case. It's also I need to be able to traverse third-party trust, which is exactly what PKI was made for. This is another reason why PKI is so important for IoT security overall, and why it's the natural choice.
Right.
But all of what you see on this screen, and this is
Mhm.
this is the bright light I was talking about earlier, Tim. It's not all doom and gloom. In fact, it's a really great world to be in right now, because all of these extremely major organizations and consortiums represent hundreds, if not thousands, of vendors who have all chosen to come together in various industry consortium. And what they all have in common is they've chosen PKI at the center of the security strategy. It,
Yeah, and so I think one of the examples that you gave me once upon a time that I really like here for the interoperability is an automobile. It's such a great example because it's a complex product. It involves many electronic components coming from many different providers, and those get assembled together in that automobile. And so you need interoperability because you don't own your whole situation, right? Like, long gone are the days of Henry Ford where everything happens in my factory. And instead, I've got a deep and sophisticated and complex supply chain, and I need to be confident that I'm not going to have an interoperability problem between all of these components. And likewise, if you're a supply chain provider, your components are going out to a variety of vendors. And so on that end of things, you need to have utter confidence in the interoperability as well. Because, the same thing that I give to Toyota is the same thing that I give to Mercedes Benz, is the same thing that I give to Hyundai, and it has to work. And so this is where you really see, once upon a time, if I was running PKI on my floor, on my servers, in my air conditioned room, then I owned everything. I didn't care so much. I knew if it worked or it didn't work. But in the world of IoT, you can never own everything. Right, Jay?
it's getting increasingly rare. It's almost unheard of now to have a single source supply chain.
Yeah.
And in fact, we could probably have a webcast just about PKI solving interoperability issues within the supply chain. That's an enormous issue, and it's with the reason why PKI is the natural solution. However, even if these particular consortia are concerned with finished devices going out into the field,
Hmm.
that need to have PKI at the basis of how interoperability works amongst all the third parties that need to trust each other to some level. And this is the bright light, Tim, because whenever interoperability enters the arena, it's not just a internet connected teddy bear. Now it's a internet connected goodness knows what, where several third parties have to be able to connect to it. PKI is the solution to that. And thankfully, those are the kinds of that'll be the generation of devices that you won't see on the Mirai botnet, thankfully.
Right, exactly, and that's what we're getting to now. Directly related to all of these topics is our recent acquisition of Icahn Labs. So we get a lot of questions about this. What is Icahn Labs? How does it fit in? And since this is very important to how we deal with PKI for IoT, I just thought we should explain it to the listeners here.
Sure. As a trusted third party CA, obviously one of our core skills, core competencies was the ability to stand up PKI infrastructure, issuing CAs, protecting routes, all those things that are important for PKI vendors.
Hmm.
But so therefore, we were able to hand off the certificates to the customers, and they were very happy with them. The problem is we needed to beef up the technology for actually securing the device, because there were so many things happening at the bootstrapping of the device itself, whether at the foundry or at the assembly point or somewhere along the life cycle of the device, where the certificates were being, basically put into the device. The ask from a lot of customers was, can you help me to provision the device itself? We need
Yeah.
some more technologies, but can you also help me to do things such as code sign and verify the integrity of my firmware? And that obviously needs an X509 certificate. So since I'm doing it with your certificate, can you help me with the technology that does that integrity check? And that's where Secure Boot
Right.
comes in.
Yeah,
Also,
if I use an X509 certificate to secure the identity of a device that was already compromised before the certificate was put on it, then I didn't really solve anything,
that's
right?
right. I might even have a very modern device that has some other kind of secure element, a TPM, Trusted Secure Computing Group TPM chip,
Right.
as an example. Can you help me with some code, with some embedded software to be able to then not just provision the certificate, but also put it securely into the TPM, and on and on. So in other words, it's all about device hardening and taking advantage of the fact that you are choosing PKI as a security infrastructure, and you're using a security partner. You would like to sole source a lot of these technologies from one vendor, and we were starting to hear that quite a lot. And we knew of Alan Grau, who was
Mhm.
one of the co-founders over at Icahn Labs. We knew about his technology, and they were moving towards PKI infrastructure because their customers were asking them for more PKI to be able to harness the embedded software that they were building. And we were the natural PKI company to come along and go, you know what, maybe this is a good acquisition for us. We'll use your IP in a lot of our customer engagements, and I think it's
Yeah.
working out very well.
Great. And being able to combine that with a public CA and our availability to issue and manage in volume and automate and all the rest winds up being a really good combination. So because we're running up against our allocated half hour that we promised to keep it to, let me take just a second to plug the podcast. Jason and I do this on a pretty regular basis. We go into depth on a bunch of different issues. It's really all things PKI, certificates, cryptography, trust models, etc. And we are podcasting on a pretty regular basis. We've published nearly 20, I think like 15, 16 episodes so far, and they keep coming fast and furious. So you can find us on iTunes, Spotify, SoundCloud, and a bunch of other places where you may listen to podcasts. Just search for Root Causes or Jason Soroko or Tim Callan, and you ought to be able to find it. So please come listen to our podcast. We love to have more audience members. And with that, I think we're ready for questions. Mark Anthony, how are the questions going?
Hey, Tim. Happy to be here. The first question I see right now is a little bit
Okay.
of a doozy.
All right.
One viewer says, I agree that botnets are a bad thing. Unfortunately, I have to balance my limited time and resources on a lot of potential threats to my company. Tell me how I can justify prioritizing these resources to fight botnets on my IoT devices over other potential threats to my operations and information.
Right. So this probably was written while we were talking about Mirai botnet early on. Jay, you want to grab that one?
Yeah, sure. So the Mirai botnet, I think one of the things you're going to start to need to worry about a lot more. It's funny. A lot of enterprise IT podcasts are talking about things such as GDPR, privacy.
Mm-hmm.
They're talking about things such as other things that might not seem like they play a role in the OT world, the operational technology world, where a lot of this IoT stuff plays. You mentioned automotive, you mentioned aviation, but there are a lot of use cases such as healthcare, where patient information might be passed from device to device or from device to the cloud. So therefore, I can see how a lot of vendors would perhaps try to keep it simple.
Yeah.
a lot of vendors who obviously were, I think at least half of the slides in this particular webcast were about being very sensitive to the fact that you do have a cost crunch. You do have cost sensitivities, you do have lack of time. You want to get that product out to market, or your users just won't accept something that's complicated. Therefore, even if it's the best in the world, you won't implement it if it's complicated or difficult. So therefore, we're trying to be as sensitive as possible to the fact that even things such as, in a surgical theater, for example, you might say to yourself, yeah, I know all about PKI, and I just can't imagine something like revocation being allowed in a scenario where, a doctor is doing surgery with an IoT device.
Right.
And it's interesting because the answer to that is, well, you just shorten the lengths of it's shortened the lifespans of the certificates, and
Right.
therefore, the certificate will live by definition throughout the lifespan of the surgery. So it's the same thing with a car. It's the same thing with an airplane. When there are critical operational periods, you ensure through the trust model and the definition of the certificate policy that those kinds of use cases are covered properly. So therefore, Tim, I think we back up and tackle that question, at the highest level. It's basically, this is purpose-built PKI for IoT.
Right.
We kind of touched on that concept, but we could probably have whole webcasts about specific use cases and how purpose-built PKI for IoT makes a huge difference in getting this right and addressing not just the scalability issues and the concerns about cost and all those things we addressed in this webcast. It really, things have evolved, and all of these various use cases are being thought about, and thankfully PKI, after the multi-decade tool set that we have, we've got the tools to get it right.
Yeah, so listener, right, part of Jason's point is that it's probably not as bad as you think it is, right? And I think that's an important point to understand. The other point to understand, if I may offer, is that if your devices are being owned and they're being used for DDoS attacks, I guarantee you're also exposed to your own problems. Like, that is no longer a safe device for you to have operating. If someone can use your device for phishing or Bitcoin mining or DDoS or whatever they're gonna repurpose it to, they can also repurpose it to stealing your secrets or disrupting your operations. And at that point, that device is compromised, that device is no good. So even if your devices are not being used to attack you today, if the capacity is there for them to attack you, you have to consider them unsafe. And I think that's an important thing, because even if you're fine today, you may not be fine tomorrow. And so at that point, they can't be accepted. I think that's the long and the short of it. What's the next question, Mark Anthony? Are there more?
Oh yeah, there's a few more. This
Okay,
one's
cool.
related to the Icahn Labs acquisition.
Okay.
Are you guys going to be doing business under the name Icahn Labs, Sectigo, or even both?
Right.
Yeah, I think I can take that, Tim.
Sure.
So Icahn Labs was acquired fully by Sectigo. Icahn Labs, because it's a recognized brand, will be maintaining that brand for a certain number of embedded security technologies. So therefore, you could be a customer who is buying an Icahn Labs branded technology as well as a Sectigo technology, and it would be Sectigo that ultimately supports it. So that's the distinction.
Cool. Next. That's a short one. Short ones are good.
Sure thing. One user says, in addition to my own connected devices, I have partners with IoT devices, where ultimately our business success depends on their network security. What can we do to deal with that situation?
Yeah, good one. So Jay, we were actually talking about this with some of the supply chain and stuff. So you know what? I know mine are all locked down, and I know I'm safe, but I depend on other people, and I don't know that they've done everything right. What do I do?
Yeah, one of the things that I've seen is, if you're the bigger partner, for example,
Yeah.
if you're the bigger partner, you potentially could write language into your partner agreements that say, hey,
Yeah.
you need to have a certain level of maturity within your organization, and that maturity could encompass things like, security capacity for the devices that you're being connected to. The ability to measure those things might not be the easiest, but at least the language would be in the contract.
Yeah.
So you could address it from a legal, contractual standpoint. However, we're technologists, Tim, so let's talk about it from a technology standpoint.
Okay.
Maybe this is where we get into, a very short conversation. Again, this could be a whole podcast or webcast by itself, where we talk about brownfield versus greenfield implementations of IoT devices. Don't know if you know this, but IoT's been around an awfully long time.
Right.
And therefore, there's an enormous number of connected devices that have been implemented in the world that will be implemented for the rest of my working life. And what can you do about that? Well, thankfully, in IoT, there are concepts such as gateway technologies, where you can basically at the edge of the IoT network put in some a passive network monitoring or something like an embedded firewall to be able to watch for bad things. And those are the kinds of things that you might say to your partner, hey, you might want to actually implement some of this technology before I deal with you with your brownfield devices. So thankfully for brownfield, there are passive ways of retrofitting a network. However, for greenfield devices, I think this comes back to the supply chain story, Tim, which is perhaps the partner can say, listen, we're working on a new project together. There's going to be new devices. Before we go and acquire that technology, let's go to our supply chain and measure the level of security being put into those devices. And heck, if it doesn't even pass muster with legislation, you're in big trouble. So therefore, talk to a security partner, and the security partner, such as a Sectigo, we're really, really experts in doing a lot of business development between your partner and other people up the supply chain to make sure that the brand new greenfield devices that you're about to implement are actually secure. So that's
so you make that part of the design phase almost.
And Tim, I actually even have another suggestion, which is a lot of those consortiums that you saw flashed on the screen earlier, check into them, because perhaps your industry either belongs to is being very well represented by one of these, or perhaps there are other consortia that have already solved a lot of these problems for you, and therefore just join the consortium, see what they have to talk about, and perhaps implement their version of the technology, which might be ideal for your particular rollout. And I highly recommend doing that.
Yeah, that's a great suggestion. That's the reason these things exist. And a lot of these consortia have done the hard work of trying to figure out how PKI fits into their particular use case. And, you've got different use cases here, right? Like, Aeromax is all about the aeronautics industry. Joint venture Silicon Valley is about smart cities. Sunspec is about energy. So, they've looked at their particular niche and they've figured out what PKI needs to be for them. And these are great sources of information for how to do this. I think that's a great suggestion, Jay. Mark, do we have any more questions?
Yep, we got one more for you guys.
Okay, what's that?
Question reads, I recently read an article that SHA-1 is now insecure. Do I need to worry about that as part of my and others' IoT networks?
Yeah, I think we probably read the same article, listener. It was about a week ago. What happened was there was an advance in SHA-1 collision attacks where a chosen prefix collision attack was demonstrated by some researchers. I don't have their names in front of me, but it was a first-in-kind demonstration. Jason, what is a chosen prefix collision attack?
I guess to simplify it as much as possible, there are all kinds of clever ways to make guesses at what a prime number is. Let's just put it there. And not just prime numbers, but also other forms of, hey, I think I can guess what part of the hashed value is based off of something I see in the hash, something that I might be able to guess because I know how the calculation was done. So therefore, what we're talking about is sometimes even much, much smaller, very, very, very clever ideas of essentially guessing. If I can optimize my guesswork when I'm trying to create a collision of, hey, I can create the same hash from a different value. The ability to create that hash based on really good guesses is what we're talking about. In other words, Tim, the guesses are getting better.
Right. So you're reducing the number of combinations. Like in principle, you could try, if you had enough computing power and enough time, you could try every key combination until you found the right one. But the number is the likelihood of getting it right is so vanishingly small that we consider it not worth worrying about. But if you can reduce the number of guesses you have to make, then the amount of time and processing power it takes to get there goes down. And somewhere along the line, you get to the point where it becomes economically feasible. And what the chosen prefix means is instead of just colliding on whatever you happen to find, you actually pick your target. And your target could be this CA's root or this large financial institution's critical certificate, right? And if that's your target, that can be a very high value outcome. I think upshot is that SHA-1, you shouldn't be using SHA-1. Right? SHA-1's days are gone. 15 years ago, it was de rigueur, but now it is overpowered by cryptographic techniques and computing power, and we just need to be getting off it. Do you agree with that, Jay?
I agree with it to the point where we will probably see other cryptographic algorithms that we use today becoming declared obsolete in the future.
Yeah,
for various
absolutely.
reasons. And it has to do with, go ahead, Tim.
I was going to say, so your public certificates are fine, right? If you're using code signing or SSL or SMIME, don't worry about it, right? Those vendors, those public CAs got away from SHA-1 a long time ago because the industry knew that it wasn't going to last. However, for your bespoke private CA, internal PKI kind of environments, you may still be using SHA-1. And if you are, you got to stop. Phase that stuff out. Get rid of that algorithm. Can't hash with SHA-1 anymore. It is no longer secure.
Tim, there will be IoT devices born today that will live long enough to see the expiry date of the cryptographic algorithms that we use today.
Right.
And it's just another example of don't do this stuff yourself. Come to the security experts.
Right, and that's one of the other things you get out of purpose-built PKI is it's agile, and part of agile is we can change those things as we need to. So Mark Anthony, next question.
That is all I have for you guys today.
Cool. All right, well, that's good because we're up against our time anyway. So Jason, audience members, thank you for the insightful questions. Thank you for joining us as always. Jason, thank you for your insights as always. And of course, I got to plug it one more time. If this sort of stuff is interesting to you, we cover lots of similar topics in depth, and we really get down to the nitty gritty, and we would love to have you listen to us at Root Causes, the PKI and Security Podcast.
Thanks, Tim.
Thanks, Jay.